Welcome to another deep dive. We're going way back to the 16th century to explore the work of Nicolaus Copernicus.
Copernicus.
You know him.
Oh, yeah. Big guy in astronomy.
He is. We've got excerpts from his book, De Revolutionibus Orbium Coelestium.
That title's a mouthful.
It is. And it's a book that completely changed how we see the universe. I mean,
Mm-hmm.
before Copernicus, everybody thought,
Earth was the center of everything.
exactly, it's like we're the big cheese, you know?
Right, the Ptolemaic model. Ptolemy, that was the guy, centuries earlier, came up with this Earth-centric model. You know, Earth at the center.
It was so complex, though. Remember those? To explain how planets moved, they came up with epicycles.
Oh, yeah, ectocycles.
Little tiny circles on top of the bigger orbits around Earth.
It's like picture planets making these tiny loops as they go around.
Crazy, right?
A little bit. But, you know, for centuries, everybody thought that's how the universe worked.
Totally. Copernicus himself, I mean, even he knew how hard it was to change people's minds about this. There's this part in the preface of his book where he's talking about how weird it might sound to say that the Earth actually moves.
He knew he was rocking the boat, for sure.
Yeah, big time. But get this. Through all his observations and calculations, Copernicus reached a different conclusion. He proposed that the sun, not the Earth, was the center.
The heliocentric model, that's what we call it.
Right. It wasn't just some random idea either. Copernicus had really studied the work of astronomers who came before him. Like he was looking for a better way to explain how planets moved and putting the sun at the center.
Make things so much simpler.
It did. One thing that bugged Copernicus about that old Earth-centered model was how it explained retrograde motion. Ever notice how sometimes planets look like they're going backwards in the sky?
Right, like they're doing these loop-de-loops.
And to make that work in the old model, they had to add those epicycles, remember?
The extra little circles.
Yeah. Copernicus figured out that if Earth was also moving around the sun, that backward motion,
Makes total sense.
it's like when you're passing a car on the highway, right?
Right.
For a second, it looks like the other car is going backwards.
Perfect analogy.
Much better than planets making cosmic U-turns, right?
Definitely.
And there's another thing. Copernicus was thinking about how the brightness of planets changes. Now, if they were all just going around the Earth at the same distance, they should always look the same brightness, right?
You'd think so.
But astronomers were seeing these planets getting brighter and dimmer at different times.
That's right.
Copernicus, he figured out this change in brightness makes sense if the planets are going around the sun at different distances from us.
Closer, they look brighter. Farther away, dimmer.
It wasn't the planets themselves changing. It was our position as we all moved around the sun, like a cosmic dance or something.
Nice cosmic dance.
And speaking of dancing, Copernicus, he also spent tons of time watching the stars, and he noticed their positions. They seemed to shift a tiny bit over time.
Very tiny, but he noticed it.
Now, in that old Earth-centered model, stars were supposed to be fixed, not moving.
Right. But Copernicus, he proposed this tiny shift was because of something called precession.
Precession. Okay. Explain it to me like I'm 5.
All right, so picture a spinning top.
Okay, got it.
As it spins, it wobbles a little on its axis, right?
I see that.
Well, the Earth kind of does the same thing, but super slow.
Okay.
Its axis of rotation wobbles over thousands of years. And because of that wobble, the positions of the stars look like they're changing a little bit from our point of view.
So the Earth is spinning, but it's also wobbling.
Exactly, a little cosmic dance, right?
That's 2 cosmic dances.
Yeah, and that tiny change in the stars' positions over centuries, that was more evidence for Earth's movement.
Mind-blowing, right?
Yeah.
That Copernicus figured all this out just by watching the sky.
Mm-hmm.
And he wasn't done yet. He was a math whiz, too.
Oh, yeah, De Revolutionibus, it's full of complicated math, tables, and calculations. He was using trigonometry, imagine, to figure out how far away planets are and how long it takes them to go around the sun. He even calculated the distance to a star called Spica.
Hold on. To a star, this is way before calculators, right?
Way before. His calculations were incredibly precise, and they showed that if you put the sun at the center, you could predict where planets would be, even better than with the old Earth-centered model.
So he wasn't just saying, hey, maybe the sun's in the middle. He was backing it up with serious math. But it wasn't all about numbers. Copernicus was also into the moon.
The moon.
Yeah. He was using lunar eclipses, you know, when Earth's shadow falls on the moon,
Right.
to figure out more about how the moon moves and how far away it is. He used a technique called parallax for that.
Parallax, yeah. It's like,
Yeah.
hold your thumb out and close one eye, then the other.
It jumps back and forth.
Exactly. By looking at the moon from different spots on Earth during a lunar eclipse, Copernicus could calculate its distance. It's basically geometry, but on a cosmic scale.
So he's changing how we think about the solar system, and he's coming up with techniques that'll shape astronomy forever.
He was a pioneer.
That's amazing. But there's more, right?
Oh yeah, there's so much more.
Let's get to it.
Remember how Copernicus used parallax to figure out how far away the moon is? Well, he thought about using it for stars, too.
For stars. Wow, that seems really hard, especially back then.
Oh, it was a huge challenge. He thought if Earth is going around the sun, then as we move, nearby stars should look like they shift a little, compared to really far away ones.
Kind of like when you're driving and the trees by the road seem to zip by faster than the mountains way off in the distance.
Exactly. Copernicus called this shift stellar parallax. He thought if we could measure it, we could prove Earth was moving. But there was one problem, even though his idea was right. The instruments back then
Weren't good enough.
not even close. It took centuries before telescopes were powerful enough to actually measure stellar parallax.
So Copernicus had the right idea, but
Just way ahead of his time. When they finally did measure it, it was a huge victory for the sun-centered model. And it gave astronomers a way to measure how incredibly far away stars are.
it's amazing that he figured that out so long ago. But, we've been talking about how Copernicus revolutionized astronomy, but his model, it wasn't perfect, was it?
Not quite. Copernicus was still thinking in terms of those old Greek ideas
Which were?
that everything in the heavens had to move in perfect circles.
Oh, right. And we know now that planets actually move in ellipses?
Slightly oval-shaped paths.
Right.
It took another brilliant guy, Johannes Kepler, to figure that out. He built on Copernicus's work.
So Copernicus didn't get everything right,
Yeah.
but he got us moving in the right direction, you could say.
Absolutely. We also have to think about when Copernicus was doing all this. He published De Revolutionibus in 1543.
The year he died.
Yep. And back then, going against the church's teachings, saying Earth wasn't the center.
That was dangerous stuff.
For sure. It took a lot of courage to put those ideas out there. But what Copernicus did,
It set off a chain reaction.
it did. It's like he opened a door and astronomers like Galileo came rushing in.
With their new telescopes.
And they saw things that backed up the sun-centered model even more.
Then Kepler refined the model with his laws of planetary motion,
And then Isaac Newton came along with his law of universal gravitation,
explaining why planets move in those ellipses.
and giving us a way to understand the force that holds the entire universe together. It's incredible.
Copernicus really sparked the scientific revelation, wouldn't you say?
No doubt about it. And that revolution is still going strong. Think about everything we've learned since Copernicus's time. Galaxies beyond our own, the universe expanding, black holes, the cosmic microwave background radiation.
Whoa, that's a lot. We've come so far in understanding the universe.
And it's all thanks to pioneers like Copernicus. They dared to question what everyone thought they knew and looked at the universe in a whole new way.
It really makes you wonder, what would Copernicus think if he could see how far we've come? If he could look through a modern telescope and see the universe as we know it now?
I bet he'd be blown away. Imagine him staring up at the night sky, seeing all that's out there.
I can almost picture it. All those galaxies, all that space. I wonder what he'd ask about first. Dark matter, dark energy.
Those are good ones. Or maybe those mind-bending black holes warping space and time.
You'd probably be full of questions, just like astronomers today.
Because that's what drives us,
Yeah.
right? That desire to understand the universe and our place in it.
That endless curiosity. It really blows my mind thinking how much we've learned about the universe since Copernicus. We went from the simple idea of the solar system to this giant universe with galaxies and black holes and all kinds of crazy stuff we're still trying to wrap our heads around.
It's pretty amazing, all thanks to human curiosity, people
Yeah.
wanting to learn more and more. And it all started with folks like Copernicus, who thought differently, who dared to imagine the universe in a new way.
His work wasn't just about the solar system. It was about, the spirit of science, questioning everything and being open to new ideas.
Exactly. And that's more important than ever. And think about it, we're still trying to understand the really big questions. What is dark matter? What is dark energy? How did the universe begin? Is there life out there?
Man, those are some big mysteries. And I bet Copernicus would be right there with us, trying to figure them out. This deep dive into his work, it's really shown me how important it is to observe, to calculate, and to think outside the box. It's crazy how his ideas, even though they weren't perfect, paved the way for so many incredible astronomical discoveries over centuries.
It's true. Sometimes the most important ideas, they change and get refined over time. And it's up to us to keep building on the work of those who came before us, keep pushing the limits of what we know.
You know what? This deep dive has really got me fired up. I'm ready to grab my telescope and get a closer look at all those wonders out there.
And for anyone listening who's feeling inspired, there's a whole universe waiting to be discovered. Read a book about astronomy, visit an observatory, or explore online. The cosmos is full of amazing things, just waiting to be found.
So keep looking up, keep asking questions, and keep exploring. Who knows? Maybe you'll be the next Copernicus and make a discovery that changes everything we know about the universe.
And on that note, it looks like our journey into the mind of Nicolaus Copernicus has come to an end. Until next time.
Clear skies, everybody.